Hi, welcome. My name is Inigo Marco, and I am excited about showing you at the Manufacturing Technology Conference the hybrid manufacturing capability that we have developed at 3D Systems. So, what is hybrid manufacturing? This can be a very broad concept. Hybrid manufacturing typically involves the combination of different techniques during part manufacturing, such as 3D printing and machining in this case. Here I am showing you an example of a face milling tool which is produced by hybrid manufacturing. First, we need a machine clamping interface, and then we can 3D print a part on top with, for example, improved performance or weight reduction. In this case, the cutting fluid flows accurately towards the cutting edge of the tool in an organic spiral. This offers the possibility to recycle the clamping interface, and it can improve the performance of the tool. In order to have good quality parts, the concentricity of both parts need to be very accurate, and therefore a good alignment between the preform and the printed part is needed. And this alignment technique has been developed at 3D Systems. And how do we do this alignment? First, we need to collaborate closely with the machining partner to have the preforms accurately made with certain referencing features. Then, we need to design the printed area in 3D Expert, as well as think of a way of clamping the preform inside our printer, the MP350. Once the part is inside our printer, we can perform the alignment by scanning over the referencing holes and detecting their position. Then, our DMP control software, integrated within the printer, will automatically correct the printing position for the AM part. Then, we need to make sure that we have a flat surface to start printing with a thin layer of powder and start the printing process. Once the printing process is finished, the part can be removed from the machine, and in this case there is neither need to remove supports nor cut the part from the base plate. And finally, the rest of the post-processing can be done, such as post-machining, heat treatment, surface treatments, quality control, etc. Here I want to show you a semicon application where hybrid alignment is also applied. This demonstrator is produced in collaboration with BNS Technologies and will be present at this conference. So the initial design idea for this part is to machine 3 different parts and then weld them together, which is a challenging to do operation in a reliable and accurate way, while the risk of leakage is in there. Thanks to hybrid manufacturing, we can pre-machine a cylindrical block and print the red nozzle at the top that you see in this image. This AM part will have a rather small cost and very short lead time. And additionally, we eliminate the risk of leakages, and thanks to design for additive manufacturing, we can bring added value and improve the fluid flow by having a more organic internal channel shape. But let's go one step further. What if we combine the printing process of 2 different materials? That means, for example, printing a part in copper and then on top a part in Inconel. In this example, a copper alloy and Inconel is combined. GR Copper 42 and Inconel 718 are both typically applied at high temperature operating conditions. GR Copper 42 offers a high thermal conductivity, while Inconel 718 can give a great mechanical performance at high temperatures. These 2 materials are extremely soluble and perfect to combine by our hybrid manufacturing capability. So thank you for listening, and I look forward to meeting you at the Manufacturing Technology Conference to give you more details about hybrid manufacturing, to discuss any of your applications, and show you the amazing technology that we offer at 3D Systems.